All right, this is 5.2. This is the third video. So we're looking at problem number 4. Again, this is transformation. And so T is from T3, R3 to R3. So both are in the same dimension. So we need to find the kernel. Okay. So again, X, Y, Z, and then this is my matrix. Let's create the matrix like a 1, 0. Let's look at a 1, and then there's Y 0, and then Z is like a -1, and then you see that I create just that the matrix over here according to this one, and then X is X, Y, Z, and then your output has to be 0, 0, 0 because that's your kernel, right? Definition of kernel. So what is the value of that? What is this vector? What are these vector that makes this output 0, 0, 0? All right. Again, I know just to make it short, this video, make it the video short, I just change this one into reduced row echelon form like that. Okay, that's going to be reduced row echelon form. So when you look at this one, what are the what are the pivot columns? Like a 1, 2, 3, all of them are pivot columns, right? So that means, what does that mean? That means column space of A is going to be 3. Dimension of column space of 3 A is going to be 3. Or you could write down, what is the column space on this one? Sorry, column space of A is going to be span of all these vectors: 1, 1, 0, 0, -2, 1, and -1, 0, -1. So all these vectors, span of all these vectors is going to be your column space. Okay, because they're all linearly independent because of that, all right? Because you can see a row echelon form. So that means the kernel of T is, that means 0, 0, 0. What is 0 vectors? What does that mean? So if I have 8 of 0 vectors, that's the only possibility to get to 0, right? That's why the kernel. So dimension of kernel of A, kernel of T is 0. Dimension of column space of A is 3, and that's your dimension of V. Okay. All right. I hope this helps here. So let's. What about using this one in a calculus, like a derivative, right? Again, the second derivative of any continuous functions is and goes to this is a second continuous function. Like you do the derivative, and you can again it's a continuous, right? So this is a continuous function. So so second derivative has to be 0 to find the kernel, right? So what kind of function we needed? So think about, like, if I have a linear function, if I do the derivative of linear function, you're going to get constant, right? Constant. Derivative is going to constant. And if I take the derivative of constant, that's going to be 0, right? So that means my the input has to be the families of linear function, right? Where the second derivative is going to be 0. So thus the kernel of d squared, this one, kernel of this transformation, what is that? Family of linear function. That makes it is 0. Okay. Again, you look at this one too. You can look at, I'm going to just to go here. This is a transformation from polynomial, second degree polynomial to second degree polynomial. Okay. So here, this is a polynomial. You take input and your output looks like that. Okay. So identify the transformation, give its kernel. So again, if I use that transformation, this is the input and output is going to be like that. That's how they define it, right? This is not even a second degree. Like you guys, your other degree is like other term is going to be 0. That's why I didn't put it there. Now this has to be 0. This has to be 0, right? This has to be 0. What is the possible? When is this 0? When x a is 0, when b is 0, right? That's the only time you're going to be 0. Okay. So that means you have a choice to choose anything for C. It doesn't matter. C does not depend anything, right? Because if A and B are 0, this whole thing is going to be 0. That means C, you can choose anything you wanted. So that means your input is, only possibility is kernel of T should be constant function. So what does this mean is like this. maybe you can think about like this: 0t squared plus 0t plus constant c, and that makes it what is that, like a 2 times a0 t plus 0. So that makes the whole thing a 0. All right, this is kind of redundant, something like that, right? But anyway, so you can see that a and b has to be 0, and c is any and can be any real number. So kernel of t is just a constant function. That's the answer. Okay, this is the answer. All right, I'm gonna go to let's do this one. All right, maybe you can finish it in quickly. This one, like transformation again from R2 to R2. All right, again, this transformation is a matrix vector multiplication. So they gave you the matrix is this one. Okay, find the kernel, image, nullity, rank, all of them we need to find out. Okay, so again, let's start with the AX. So there's a vector, we multiplied. So what is this multiplication? Matrix vector multiplication means it's a linear combination, right? Linear combination of these two columns, right? So which is the linear combination of columns of A, right? That's what it is. So what does this mean? Is a span of this one, we call it column space of A. Not always, but think about like as long as these two vectors are linearly, or these two columns are linearly independent, they're going to be like a column space of A. But otherwise, you have extra columns there, doesn't change anything, but still that's not a proper, like they are not the basis for that space, right? They are not the basis because they have to be independent, linearly independent. That I just wrote down this almost. This is almost like column space of A, but check if they are linearly independent, right? So I'm trying to check they are linearly independent or not here. So I just put that C1, C2, the linear combination has to be 0. For that, every C1 and C2 has to be 0. So in other words, what you can do is you can change into reduce row echelon form, that matrix, or that form matrix. If it come out to be like it came out to be identity matrix, right? Or this came out to be you have two different pivot columns. So that means they are linearly independent. All right. If they are linearly independent, that means when I span of these two vectors, or you can think about that columns to that two vectors, is going to give it to R square, right? That means the image of the transformation is R square. So what does that mean? That means, so if you do the spanning, you're going to get all the possible vectors in R square. So that means it's a surjective, like onto. So this transformation is surjective. And this is also injective because it's not clear injective, right? So, but I'm going to show you in a second here. This means only the vector that maps to 0 is only AX equal to 0 is only possible if your X is going to be your 0 vector, right? Because AX, your X has to be 0 vector. Then that's the only possibility you're going to get 0 vector. So that means this, right? Transformation of 0 vector is only 0 vector. So that's why the kernel of T is just a 0 vector. So that's why the dimension of kernel of T is 0. That means it's automatically injective. Remember that that's one of the theorem. If the dimension of kernel of T is 0, or the kernel of T is only the 0 vector, that's injective 1-to-1. So rank of T or rank of A is going to be what? 2 is a 2x2 matrix. It's 2. And then dimension of column of A is also 2, right? So that means the dimension of kernel of T is 0. All right, I will continue. This is similar example. I'm going to go to next video for the next problem.